morning, students. Today in this session we will discuss about the IDFT. So DFT equation, DFT equation, x of k is equal to the summation of n equal to 0 to n minus 1 x of n into w power nk. So the IDFT equation can be written as x of n is equal to 1 by n. So the summation of k equal to 0 to n minus 1 x of k into w power minus k n. So where w is equal to e power minus j 2 pi by n. Okay. Now the butterfly structure for 4-point decimation in frequency. So already we have discussed how to find the IDFT using matrix method. For example, so the x of k is given 4 comma minus j2 comma 0 comma j2. So how do you find the IDFT for this IDFT? Using the DFT to find IDFT. So x of is given. So the first step 1, we take complex conjugate of this term x of k, then 4 plus j2, then 0 minus j2. Okay. Then by using a matrix method here, okay, I will refresh. By using a matrix method, the DFT of 4 by 4 DFT matrix. So you have to find the DFT of this complex conjugate. So DFT of this complex conjugate of k is equal to matrix method. We already discussed 1 1 1 1 1 1 1 minus j minus 1 j, this is minus 1 1 minus 1 j minus 1 minus j. So the complex conjugate term 4 j2 0 minus j2. So this will be equal to 4 8 4 0. So normal multiplication. So first term will be 4. Okay, j2 minus j2 will be cancelled, so 4 only. So 4 8 4 2. Then this is step 2. This is step 1, this is step 2, step 2, step 3, step 3, conjugate the result. Again, conjugate the result if complex value and divide by n is equal to 4 to get the IDFT of x of k. X of k. So now which is equal to 1 by 4 of this 4 comma 8 comma 4 comma 0. So what is the answer here? So you know that 1 comma 2 comma 1 comma 0. So this is the answer. IDFT of this x of k. So x of k is given, x of n we found. This is x of n. So this is x of n. Okay. Similarly, now we will compute by using the butterfly structure. This is a matrix method. Butterfly structure, for example, 4 point decimation in frequency f of t, 4 point decimation frequency f of t, we will find IDFT. So how to find the IDFT for this equation? So x of k is given. So we will take x of k 3 comma 2 plus j comma 1 comma 2 minus j. So already these problems we solved in the previous session. So the x of k we determined. So now x of k we taken. So find the IDFT to get x of n. So now first step, take complex conjugate of k, which is equal to 3 2 minus j 1 comma 2 plus j, complex conjugate you take. Then 4 point decimation in frequency. You know the structure decimation in frequency and decimation in time frequency very well. So the decimation frequency, it is the decimation in frequency. So in this case, the first stage computation will be, so the decimation in frequency means input should be natural order. Input is natural order, okay, order. So x of 0, x of 1, x of 2, x of 3. Okay. So the first butterfly. So this is the first butterfly. Okay, first butterfly, lower wing should be -1. The second butterfly, I will take blue color. Second butterfly, the lower wing should have -1. This -1. Okay. So the lower wing, so decimation in frequency, so the lower wing outer, the trill factor is W04 and this will be W power W14. Okay. Then next is, this is stage 1. Stage 2, I'll take another color. So the second stage computation, each stage n is equal to 4, no, n by 2 butterflies. This is n by 2 butterflies. So n by 2 is 4 by 2, 2 butterflies in each stage. Here also there are 2 butterflies in each stage. The lower wing should have -1, the arrow mark, proper arrow mark for the computation, the 2 complex numbers. These arrow marks you have to specify, the trill factors you have to specify, all the lower wings should be -1. So the output, this is IDFT, so this will be, input is natural order, output is bit reversal order. But this is IDFT. IDFT. IDFT means x of k is given and the output is x of bitwise means x of 0, x of 2, x of 1, this is x of 3. Okay, so the output will be W04. So this will be W04. So W04 is 1. You know W04 is 1 and W14 is minus j. So the inputs now you can write, input is natural order, no? So you can write here. Okay, so 3, 2 minus j and 1 and this is 2 plus j. So input should be in the natural order. X of 0 plus x of 2. So it is x of 0 plus x of 2, 3 plus 1, 4. This is 3 minus 1, 2, 3 minus 1, 2, 2 minus j plus 2 plus j. So minus j will be cancelled. So it will be 4. It will be 4. Here 2 minus j minus 2 plus minus 2 minus j. So minus 2j. Minus 2j. Okay, the W0 is 1. This will be minus j. W14 is minus j. So this is minus j. W1 is minus j. So my minus plus j squared minus 1. So this will be j squared minus 1 j. So this will be here 4, 4. This is 2. J squared minus 1 minus plus. So minus 2j. This minus 2j only. Okay. Minus 2 1 minus 2. So 4 plus 4 here 8. 4 minus 4 0. Okay, into the same 2 minus 2 0 and 2 minus 2 plus 2 4. 4. 2 minus 2 0, 2 plus 2 4. So now you can take this is 8 0 0 4. So it is n is equal to 4, which is equal to 1 by n. IDFT will be, you know that IDFT is equal to finally IDFT of that x of k is equal to 1 by n, 1 by 4. 1 by n is 1 by 4. So we will get 2 0 0 1. 2 0 0 1. You can take the previous matrix example also. Find x of k. Example, same example you can take by using butterfly structure. So that is x of k is given 4 minus j2 0 j2. So you can take this also and you can compute and you can verify. So either this structure you can do, otherwise directly this will be you can do 1 by n. Okay, finally you can do it 1 by n. This is 1 by n actually. You can say this is 1 by n. Okay, all 1 by n. This is 1 by n. This is 1 by n. Otherwise finally you can compute. So one more problem, decimation in frequency. So take down the other problem. So x of k is equal to 6 minus 2 minus 2j and 2 minus 2 plus 2j. Okay. Similar way, take complex conjugate 6 minus 2 plus 2j and 2 minus 2 minus 2j. Okay. Then we'll check if you want one more. Say decimation in frequency, input should be natural order x of 0, input decimation in frequency 4 point, decimation in frequency f of t, find IDFT. So x of 0, x of 1, x of 2, x of 3. Okay. Then so the first stage computation, similar way. So this is the first butterfly. The first butterfly, second one, so this is the second one, so lower wings will have minus 1, okay. The second stage computation, so the lower wing W 0 4 and this is W 1 4. So second stage computation, minus lower wing should have minus 1. So this is input output. Input is natural order. The output should be bit reversal order, x of 0, x of 2, x of 1 and x of 3. Okay. So this output W04, this is W04 is 1, W14 is minus j, this is W14 is minus j. So the input should be 6 minus 2 plus 2j and 2 minus 2 minus 2j. So the 6 plus 2 8, minus 2 plus 2j and plus minus 2, 2j will be cancelled, so minus 4, and 6 minus 2, 4, 6 plus 2, 6 minus 2, 4, minus 2 plus this minus of plus 2 cancelled, this plus 4j, so this will be 8 minus 4, so W01, so 4, so this is j squared, minus 1 plus 4, so 8 plus 4, 12, 8 minus 4, 4, 4 plus 4, 8, 4 minus 4, 0. So you can, so what is the output? So 6 minus 2 minus 2j. So x of complex conjugate, the IDFT is equal to 1 by 4 of this 12 comma 4 comma 8 comma 0, which is equal to 3 comma 1 comma 2 comma 0. So this is 3, this is 1, 1, this is 2, this is attached 0. So this will be 1 by 4, this will be 0. So the decimation frequency, how to find the IDFT for the given input sequence x of k. So x of k is 6, this is minus 2 plus 2j, 2 minus 2 minus 2j. Take complex conjugate. If it is a complex, and you take some correct 3 1 2 0. Okay. So next, similarly I'll give the problems for IDFT for 8-point sequence. You draw them. IDFT, determine the IDFT for 8-point decimation in time FFT or 8-point decimation in frequency FFT. So take some problems from the prescribed textbook, exercise problems you can take, and do some of the exercise problems that are posted in the question bank you can take and you can practice. Okay, IDFT, the concept is same only. Okay, thank you.